Welcome to Edexcel International A-Level Mechanics 1. This is Mr. Mina, and today I'm going to solve question 2 from the January 2023 exam paper. Two particles, A and B, are moving in a straight line in opposite directions toward each other on a smooth horizontal surface when they collide directly. Particle A has a mass of 3 mkg. Particle B has a mass of m kg. Immediately before the collision, both particles have a speed of 1.5 meter per second. Immediately after the collision, the direction of motion of A unchanged, and the difference between the speed of A and the speed of B is 1 meter per second. Find the speed of A immediately after the collision and the speed of B immediately after the collision. Let's start with the diagram. I have here two particles, A and B. So I'm going to use two circles to represent the two particles. It doesn't matter which one is A, which one is B. So I'm going to call this one A and this one B. Inside the circles, I'm going to write the mass. So the mass of A is 3m and the mass of B is m. Above the circles, I'm going to write the speed before the collision. Below the circles, I'm going to write the speed after the collision. The particles are moving in a straight line in opposite direction. So A is moving to the right and B is moving to the left. Before the collision, both particles have a speed of 1.5 meter per second. So the speed of A before the collision 1.5 and for B is 1.5. Immediately after the collision, the direction of motion A is unchanged. So for A, it will still moving to the right, unchanged. And the difference between the speed of A and the speed of B is 1 meter per second. Since particle A and particle B, before the collision, they are moving with the same speed, particle A is heavier than particle B, and the direction is unchanged. This means particle B will reverse. It cannot pass through A or jump over A, so it must reverse and reverse with a faster speed because it's lighter than A. So if I call this one V, the difference is 1 meter per second, so B, because it will be faster, it will be V plus 1. The question is asking to find the speed of A and the speed of B after the collision. So by applying the conservation of linear momentum, which is the total momentum of A and B before the collision equals the total momentum for A and B after the collision, which is the rule M1U1 plus M2U2 equals M1V1 plus M2V2. For questions about momentum and impulse, the direction is very important. So since I have three of them here to the right, I'm going to take the right side as my positive direction. M1U1, M1 which is 3m, U1 which is 1.5 positive, plus M2 which is m, U2 which is 1.5 but opposite of my direction, so it will be minus 1.5 equals, after the collision, M1 which is 3m, V1 which is V, positive, same direction, M2 which is m, V2, V plus 1, positive, it's the same direction to the right. Let's simplify. We can cancel m from all of that. 3 multiplying by 1.5, that's 4.5, minus 1.5 equals 3v plus v plus 1. 4.5 minus 1.5, that's 3. 3v plus v, that's 4v plus 1. Take away 1, so you have 4v equals 2. Divide by 2, so we have v equals 0.5 meter per second. The speed of A after the collision is v. The speed of B after the collision is v plus 1. Therefore, so for part I, the speed of A will be 0.5 meter per second, and the speed of B will be 1 plus that. So for II, it will be 1.5 meter per second. Part B. Find in terms of m the magnitude of the impulse exerted on B in the collision. The magnitude of the impulse will be opposite the direction. Since B was moving this way, the impulse will be the opposite way. So that will be the impulse. The impulse is the change in momentum. It's the momentum after the collision minus momentum before the collision. So if I have, this is my particle B, the mass is m, was moving that way with a speed that is 1.5. After that, it reversed with a speed that is 1.5, and that's the direction for the impulse. The impulse is the change in momentum, so it will be the momentum after the collision, which is mv, minus the momentum before the collision, which is mu. The direction also is very important. The impulse is acting to the right, so I'm taking the right side is my positive direction. So the impulse will be mv, which is 1.5 positive, minus mu, opposite direction, so it will be minus 1.5. So we have 1.5 m, minus minus is positive, 1.5 m. So our impulse will be 3 m, and the unit is Newton second.